Hey everyone, this is Henry from Outerbridge. Today we are going to take a look at Chainlink Functions and how we can use that on Outerbridge. So to begin with, what is Chainlink Functions? Chainlink Functions is a new feature released by the Chainlink team that allows your smart contract to execute a piece of JavaScript code. So this code will then be sent on to the decentralized Oracle network, and each of these Oracle nodes will then execute the same piece of code. In the end, they'll all collect the results and send back the response to your smart contract. So the code can be really anything. It can be executing any APIs call, can be doing some off-chain computations or calculations. So today we are going to take a look at how we can actually call a webhook from Outerbridge using Chainlink functions. Why use Outerbridge at all? First of all, is that developers still have to write your own code and then come up with your own API solutions, reading the third-party documentations, while Outerbridge already have around 60 plus integrations that have already been implemented by open source developers by Outerbridge team that allows you to just plug and play. The second thing is that currently Chainlink Functions has a side effect that it will cause multiple redundant requests to be made. The reason being, each of these Oracle nodes execute the same piece of code on a chain. So if you would execute some post request that is, say, to upload data onto Google storage or to send a message to Discord, it will cause multiple requests being made. So this is why Outerbridge has come up with solutions to use a sticky session ID to allow each of these Oracle nodes to have the same session ID when they are executing the same request. At the end, Outerbridge will detect if they are being sent from the same Oracle node, hence preventing multiple redundant requests to be made. So you can find out more technical implementations from our official GitHub repository. Today we are going to build a simple workflow that is going to send a Discord message and return the message that was posted as a response back to a smart contract. The goal is to trigger this workflow using Chainlink functions. So here we have prepared a simple workflow template for you ready to be copied, and just log on to the Outerbridge app, or you can use your self-hosted version, open a new canvas and paste it there. So the first node is Chainlink Function Webhook. This webhook node will get triggered when a HTTP call is being made from a smart contract. So you can select post of get method. I'll just use post method for now. And authorizations, you can specify an API key to be included in the header or none in this case. And then now we are ready to test a node. Click a test node, copy the URL, and open up Postman, a new request, pasting the link, post request, and we are going to input the body, which is a message and hey Discord. Click send, go back to the canvas. We also can see the response being printed out here. You can see the body of the message. Perfect. Now on to the second node, which is Discord. So you need to replace the webhook URL with the channel that you want to post in, and you can easily get that URL from the channel, edit channel, integrations, webhook, copy a webhook URL. If you don't have one, create a new webhook. Then just paste it in there. So the content, what kind of content you want to post in the channel. So the good thing of Outerbridge is that you can easily map an output response from your upstream nodes. In this case, I'll just use the message over here. Click save and continue. Now click test node. Let's see if the message successfully posted on Discord. Hey, we can see it there. Perfect. So now onto the last node, which is a simple JavaScript node. Here we are just going to return the message that was posted on Discord. Again, you can easily map whatever variables that you want from upstream nodes. Discord, I'm going to just select content, save. Now click test node. You can see the data has been successfully returned to us. Now let's save the workflow and deploy it. So now we have successfully built a simple workflow that is going to get triggered when a HTTP call is being made on the particular webhook URL and send a message to Discord and finally return the message do our functions. Now moving on to the step 2, which is to trigger this workflow using Chainlink Functions. First of all, in the terminal, clone default repository here. Second step is to cd into the directory and switch to the correct branch. Lastly, do npm install. Okay, now our installation has finished. Let's open up this in your code editor. And first thing first, we're going to create a new file, .env file, and put in the RPC URL of the Mumbai and the private key of the wallet. The next step is to compile your contracts. Then the next thing is to look for this file, function request config.js, and search for these variables, message to send, and replace with whatever message that you'd like to post on Discord. So in this function request config.js file, message to send, you can replace with whatever message that you like to send. And the next step is to look for another file, which is function request source.js, and replace with the webhook URL. In this file here, so at the line 10, replace this with your webhook URL from Outerbridge. Copy the URL, paste it there. So if you are running Outerbridge locally, you can use the tunnel URL, or if you are using a cloud hosted version, just copy the URL over here. Now, the next step is to simulate the request. Save it. And you can see the response returned to us is data hello Discord. And if we go to Discord, hey, we can see it there. Go back to the workflow and do a refresh. You will be able to see there is one execution that has been successfully executed. And you can see the output response of each of the node. Perfect. Now we have finished simulating. The next step is to follow the guides to configure your on-chain resources. First, we need to deploy a smart contract to one of the testnets, and in this case, we'll be using Mumbai. The second thing is to create a Chainlink Function subscriptions that allows your smart contract to execute those requests and then pay via link. After that, you should be able to get a subscription ID and your contract address. So execute this command and replace with your subscription ID and the contract address. In this case, I have an ID of 338 and here's my contract address. Click yes to continue. Perfect. Now we can see the data has been returned to us, and this data ideally will be returned to the smart contract as well. So if you go back to your workflow, see now we have one execution. If we refresh, we'll be able to see two executions now. Go back to Discord and we can see another message has been posted. So to summarize, first we are able to build a workflow that is going to send a message to Discord and return the message to your functions. And the second thing is that we're able to test this workflow locally. And the last thing is we're able to trigger this workflow using Chainlink Functions. Take a look at some of the workflows that some of the users are using. So first you have the Chainlink Function Webhook, and you can get the ERC20 balance from an account and get transactions data. And even you can get a contract source code using Etherscan and detect bug using ChatGPT and return the results to your functions. Again, with Chainlink Functions, you can really do anything. Connecting to off-chain API, getting on-chain data, and etc. Alright, that's all for today's demo. Hope to see you guys in the next video.